Hey guys, welcome back to Consistent Code. So today's problem of the day is help Ishaan. So what we need to do in this problem, that we are given an input n, and what we need to return is the difference between this given n and the closest prime number to this n. For example, we know the prime numbers are 2, 5, 7, 10 and 11 and so on. So if you will consider the given number 10, then the closest prime number on the left of 10 you can find there is 7, and on the right there is 11. So the difference between 10 and 11 will be 1, and the difference between 10 and 7, we need to check the absolute difference. So it should be, if you will take 7 minus 10, it will be negative, but you need to take it as a positive difference. So I'm just taking 10 minus 7, that is 3. So like this, you can see 11 is the closest number, so 11 minus 10, that is 1, will become the answer. So now I hope you got the idea what we need to do. So now let's solve this problem. So how we are going to solve this problem? So what we can do, we can just create we can just check out the constraints. So the constraints are only till 10 to the power 1 2 3 5. So the constraints are only till 10 to the power 5. So we can just create a array, right? We can just create an array in which we can just store all the prime numbers till this range. So let's just create a vector of prime. Now in this vector, I'm just gonna push all the prime numbers in this range. All right, so let's do that. And also let's just create a variable check to check if we have stored all the prime numbers or not. So we will just say if initially we are not checked, we are just gonna run a function pre-calculate, that which will compute all the prime factors in this range in the given constraints. And after we have done that, all that we need to do is, and even before that, we need to just check one more thing, that if the n is less than or equals to 2, we can simply return 2 minus n. Why? Because n will be starting from 1. So if there is 1, then the prime number closest to 1 is 2. So 2 minus 1 will become 1, and that is our answer. And if it is 2, then 2 is itself a prime number, so 2 minus 2 will be a 0. So we are getting correct answer for these cases. So we can just put this condition before, and then we can just pre-calculate for the other cases. And what we need to return now, let's say we will be using binary search, or I can say a lower bound function using stl. I'm using binary search, so I'm just gonna put a lower bound function for prime dot begin to prime dot end. I will just explain what I'm doing, but first let's write the code. So what value we are gonna search, the value will be n, and this will be our iterator, and we are just gonna return the minimum, because we want the closest of the absolute difference between n minus the value of you can say prime of this iterator minus prime dot begin, and the absolute value of n minus prime of it minus prime dot begin minus 1. Okay, now let's see what I have done here. We are considering that this prime array or a vector is having all the prime numbers like 2, 5, 7, 11, then 13, then 17, and so on. Now let us say let's say that n was 10. So what I am doing, I have already placed this condition. If n is less than or equal to 2, I can just return using 2 minus n. But if it is not the case, then first I will pre-calculate this prime array. That is, prime was initially empty. I will just push all the prime numbers from in this range 1 to this range, and I will just define this function at the end, but let's consider by calling this function we are having this array generated, right? So once this array is generated, what we are doing, we are just making an iterator. We are just checking for the lower bound of n. What does this mean? Lower bound of n means that we are finding a value in this prime array such that either that value will be equal to 10 or greater than 10. So we will get an iterator pointing to this 11, right? So this will be the iterator here. This that should be pointing here. So what we will do now, we are just checking that if this is the iterator, and prime dot begin is also an iterator which points here. This 2, I can say that this 2 is basically that only. So this is prime dot begin. So let me just mark this like this. So this is prime dot begin, and this is at 11. Okay, now it's correct. So this is prime dot begin. Now if I will take the difference, I will be getting the index of this prime. If I take it minus this begin difference, then I will get the index of this 11 in my prime array, and that's what I have done here. It minus prime dot begin, I'm getting the index of this 11 in this prime array, and prime of that index will obviously be 11. So now I'm taking difference of 11 and 10, and this will be one value which will be 1, and the other case also is there. When this was the case when we were having 10 n as 10, so 10 for 10 we are having the element 11 as the closest. But consider the case when n was equals to 8. So for n equals to 8 also you have prime numbers 11 and 7, but 7 would have been the closest, right? So that's why we need to consider the left prime number also. So here we have also considered that the same index we got it minus prime dot begin but minus 1, so that we can consider 11 and the element previous to it also, so that we get the closest number out of them, and that's why we have taken this minimum function. All right, I hope you understood how it is being done. Now the only thing remaining is to create this prime array, right? So now let's do that. So let's just create a function, and let's say that is void pre. So what should this function do? First of all, it should make or check as 1, because we do not want that this pre should be called again and again, otherwise our time complexity will increase. So once we just make our check as 1, that is we are marking that we have created this prime array. Now what we are gonna do, we are just gonna create an array, let's say vector int is prime, to check if the particular index is a prime number or not. And I'm just gonna make it a size 1 2 3 4 5, and let's say 4. This, let it be this size, and let's consider initially all numbers are prime except 0 and 1. So I'm marking 0 and 1 as not prime, by that is 0. Alright, now I'm considering that 2 is a prime number, so I'm just pushing 2 in my prime vector. This is the prime vector, so first of all I'm just pushing this 2 as a prime number in my prime array, and now I'm marking all the factors of 2 as non-prime. So that's exactly what I'm gonna do. I less than equals to this value, and I plus equals to 2, so all the even numbers will be marked as not prime. So its prime I will be marked as false. Now we have got one prime number 2. Now we need to get the remaining prime numbers from 3. Now all the other prime numbers are odd, right? So we can just start a loop from int I equals to 3, and I should be less than equals to, you can say, this value only, and I should be incremented by 2, because we only consider only odd numbers, because we have already considered the even numbers here only, right? So now we are dealing with the odd numbers. So for I equals to 3, and then it will iterate for every odd number. We will check if this number I is a prime number, and if this is a prime, we are just gonna mark all its vector as not prime, and also we are gonna push back this I in our prime numbers array, right? Now once we have pushed this prime number, we are just gonna mark all of its vectors beginning from 3, because I'm not beginning from 2, because that will be an even number and that has already been done. So I into j should be less than equals to this value, and j should be incremented by 2. Again, because we only have to deal with the odd numbers now, and hence I just mark this I into j as not prime, right? So once we are done with this, we should have created the prime array, and now this should be working. And the last thing I would like to say is that we just did a blunder here. This bracket needs to be here, so that now it's absolute function, and this is also ending correctly. So yeah, great. Alright, so now let's try submitting the code. And we have solved this problem successfully, and I hope you liked this explanation, and if you did so, make sure to hit the like button and subscribe to the channel, and I will see you tomorrow with the next problem of the day.